Okay, here we have another kinematics question from an A-level Edexcel past paper. This one is probably the hardest one it's been so far, in my opinion. It's definitely different. It involves two balls actually colliding in midair, which, none of the other past questions actually have this. So let's see how you deal with that. Okay, well, I'm going to deal with this the same way I always deal with kinematics. I'm going to do a horizontal suvat, a vertical suvat. You have to choose which ball to focus on first, though, right? And you've got two balls. Just reading through all the information in question, see if anything can help. Anything that's not on the diagram, maybe. So two balls, 50 meters, 20 meters per second, 30 degrees. This is all on the diagram so far. At t equals 2 seconds, they collide. So that's quite helpful. It's very helpful to know how long it takes for them to collide here. I'm going to call this point C, just so I can refer to it in the future. So at point C, both A and B, they hit that point after 2 seconds. Models particles. Okay. Initially, I'm going to choose to do my theorems on particle A because I know the speed and the angle of particle A. They're both knowns, right? With particle B, there's already two unknowns there. Let's try and sort of do that later when maybe we can calculate some more information. So I'm looking at particle A, and it's talking about, what does it want me to find? Find the velocity the instant before it collides with Q. So essentially, it wants how fast is P moving here at this point C, right before it hits. So I'm going to go particle A from A to C. I've just realised that's not particle A, is it? It's particle P, ball P. Let's rename that. Particle P from point A to point C. What's going on? Well, horizontally and vertically. S, U, V, A, and T. So U is going to be, as we usually do it, the speed is 20, but the velocity has a vertical and horizontal component, which we can split up like this. So it's going to be U cos 30 and U sin 30. So I'll just put that in there. So U was actually 20, wasn't it? So I can put U equals 20 cos 30 here. I don't know why I skipped S. I skipped S because I don't know. I don't know how far it is. S would be the horizontal displacement from A to C, right? This number here, I don't know that. That's why I skipped. Okay, V. I'm actually wanting to know V, right? A is 0, as always, and then T. Actually, no, T as well. T is 2. Okay, vertically, well, the initial velocity is actually U sin 30, so 20 sin 30. Vertical velocity, again, I want to know. A is always negative 9.8 or negative G. And T is again 2. So with all this information, actually, I have enough to define my question marks. Right? For a suvat, you need 3 unknowns and 1 known. So I'll do vertically first. Vertically, I want my V, so it's my equation with no S, no displacement. So I'll do V equals U plus AT. It's my equation with no S. So V is my question mark I want to know. U is 20 sin 30, which is actually just 10. Minus G times 2. V equals, just type in your calculator, right? This gives you 10. This is minus 2G, which gives you minus 9.6. Okay. Horizontally, you can just write it. Because A is 0, so V is just U. They're the same. If you did V equals U plus AT with A equals 0, hope you can see this equation here, right? When A is 0, you do just get that, V equals U. But you can always just use this fact in general, right? The horizontal final velocity here will always be the horizontal initial velocity. So the velocity is 20 cos 30, which is, the cos 30 is root 3 over 2. That gives you 10 root 3 meters per second. Why did I put meters per second squared here? That should just be meters per second. My mistake. There we go. It does that for the velocity of P at this point. So the velocity is, well, it's a vector, right? Negative 9.6. That's actually the wrong way around. It's 10 root 3 in the horizontal direction and negative 9.6 in the vertical direction. I would actually argue this should be full marks. I've answered the question. In the mark scheme in this year, it did show the magnitude and the direction of this vector. I would say that you fully described a vector if you've just written it in components, but let's just pretend the question asked for the magnitude and direction, which I think, if that's in the mark scheme, it should really probably be asking you for that specifically. But yeah, the magnitude or the speed, you do your Pythagoras. Right. So this thing, and for the direction, well, a little sketch would kind of help here. Just to show what am I doing here. So velocity is 10 root 3 across and 9.6 down. So something like this. 10 root 3, 9.6. And this is an angle, I'll call it beta. So beta is, for this triangle here, it's going to be the inverse tan of opposite over adjacent. So that comes out to be, so that's 9.6 over 10. Root 3, 28.9, or 29.0 actually degrees. And the magnitude, get that right, 9.6 squared plus 10 root 3 all squared, square root, 19.8. Direction, I'm going to say 29.0 degrees beneath or below the horizontal, right? You have to say a direction with this angle. Don't just say 29 degrees. It's below the horizontal. That fully describes the vector. Okay, so we found the velocity. This is a part of the question you could do without worrying about collision, right? It's part B where you have to worry about the collision, which is maybe slightly more difficult. So I'll put A here. Part B now. What's going on in part B? It's going to find about theta and u. So I'm going to need to do a theta on particle Q. Again, from B to C seems sensible because it's asking about, all we really know is that it collides after 2 seconds. So you use the information you have, right? Horizontally and vertically. Now, we don't know a lot, right? We don't know how far horizontally is from B to C. S, U, V, A, and T. So I don't know my displacement. What do I know? I know my time, 2 seconds, both of them. I know acceleration always. U is just, U cos theta and U sin theta, right? And nothing else. The trick, and this is, I could just tell you the answer, and you can say, oh yeah, it makes sense, I know how to do that. But you need to be able to do this yourself in an exam. How do you figure out what you need to do? So the way to think about it is, what information do I know? Well, what I know is that B and A, P and Q, they collide at point C. So I'm definitely doing from B to C. You've got to ask yourself, what's special about point C? Like, how do I know, how is point C defined, really, is the question. Because that's the only way you're going to get information out of it. You say, well, what exactly is point C? Right? All of this information, so the U, the A, and the T, that's nothing to do with point C. Point C could be anywhere, and these numbers wouldn't change. What makes point C special? Well, point C is a point where both balls are hitting. That's what defines where this point is. Then we need to use the fact that P and Q are both there at the same time. The easy example to see is, the vertical displacement. I could calculate how high up P would be after these 2 seconds, and that would have to be exactly how high up Q is, because they are meeting at point C. So over in my first initial theta, I'm going to use this table again, and I want to calculate the vertical displacement over here, right? So maybe I can go in a different color and just sort of squeeze it in, right? So in this case, I guess V is the unknown, and I'll use the S equals ut plus a half at squared. So U was 20 sine 30, which is actually just 10. T is 2, minus g over 2 times 2 squared. So plug that in your calculator. You should get 0.4. The particle P has moved 0.4 meters vertically from A to C, which means Q is done the same. So I can add in here 0.4. Okay, so helpful. Now you could try and run with this. The issue you're going to get is if you try to do that here, you do have 4 sort of numbers to use, but there are still 2 unknowns in U and theta. You're not going to be able to get 2 equations out of that. You're going to be able to get 1 equation. Right? I can get 1 equation out of the fact that vertically it's gone 0.4 meters. I can write the equation down, right? So it's the equation with no v. So s equals ut plus a half at squared. 0.4 equals, so t is 2, so ut is going to be 2u sine theta. And then minus g over 2 times t squared. Well, g over 2, t is 2. So g over 2 times 2 squared is just 2g. I'll write all it in properly. Okay, no need to push. This is 1 equation with 2 unknowns. Well, what other information do I know? Not only is C 0.4 meters off the ground, what else in the question have I not used yet? I'm reading through it all. I have never used this 50 meters. And obviously this answer will depend on like how far apart do A and B start, right? So it's not going to be that the horizontal displacement here is going to equal here, like it was vertically. It's more the fact that they're going to add up to 50. Okay, so working out the horizontal displacement from A to C is still going to be useful. That's over here. So, again, no v, so I'll do s equals ut plus a half at squared. And A is 0, so that's actually quite easy. S is just ut, which is 20 cos 30 times by t, which is 2. Type that in, that's going to give you 10. But cos 30 is root 3 over 2, that's going to give you 20 root 3. No mistake. Okay, so this from A to C is 20 root 3. Just calculated that. Point is, I can use that to calculate how far it's from B to C, because I know in total it's 50, right? So from B to C, it's going to have to be 50 minus whatever that number was. 20 root 3. That's here. Okay, so trying my best to fit this on one screen so you can have the question there to refer to. I'm going to get an equation out of the fact that horizontally B has travelled 50 minus 20 root 3. It's the same through that equation I've just done, the one with no v. So we will do s equals ut plus a half at squared. 50 minus 20 root 3 equals u cos theta. Times by again t, which is 2, and then a is 0. Okay, so I have one equation using the fact that I know how far particle Q has gone horizontally. That's the green equation. And I got my blue equation because I knew how far particle Q had gone vertically. Right? It had to go the same as particle P. And horizontally it had to add up to 50. Now I've got 2 equations, 2 unknowns. I can just solve them. Right? And then, any way you want to do this. Probably what I'd say is this top equation, actually going to simplify quite a bit. This is just a number. If you do 0.4 plus g over 2 times 2 squared, I think you actually get a really nice number. Right, you get 20. This blue equation is actually just saying 20 is 2u sine theta. Or really just saying that u sine theta equals 10. And that second equation is, I'll divide by 2 again. U cos theta equals 25 minus 10 root 3. So when I'm solving these 2 equations, it's kind of like those pure maths questions where you have r sine theta, r cos theta, and you eliminate the theta or you eliminate the r. Either way, it doesn't really matter. Let's just divide to get tan theta. So I'm going to do the top equation divided by the bottom equation. Right? Divide. U sine over u cos just becomes tan, the u's will cancel. And the right hand side is 10 over 25 minus 10 root 3. You can use this to find theta to do an inverse tan. So inverse tan of 10 over 25 minus 10 root 3 52.5 degrees. What I'm going to do, I'm going to store this exact value in my calculator, either using the answer button or the store function on the calculator. Substitute that value of theta back in, say to the first equation, u equals 10 over sine theta. So 10 over sine of answer gives me 12.6. That's meters per second. And I think the question was just saying, yeah, find theta and find u. So I've answered it. So a little bit tricky, but just to recap, all I did was I did assume that I'm the first particle, which allowed me to find how far had the first particle gone vertically and horizontally. And that allowed me to find how far the second particle must have gone vertically and horizontally to make it all match. So the same amount vertically and horizontally to make it add up to 50. And then that gave me two equations with my two unknowns. I was able to solve them just like I would in pure maths. Okay. Part C very quickly. Just finish this off. So part C says statement limitation on the model other than area resistance. Not using area resistance. Okay. That could affect the accuracy. You know what I always say on this, if it says state limitation on the model, you look for the word model in the question. Okay, so where does it say model? Oh, it says model here. Border model of particles moving freely under gravity. There's the big clue. This is very often just an answer there. So very simple. I'm just going to write state 1 limitation. Well, it doesn't say state 1 refinement, so I'm not going to write do not model the ball of particles. I'm going to say the limitation is the balls are not really particles. Okay, the balls are not actually particles. So what would also get your marks is if you write anything about size or spin of the balls, that all comes from that. You might be able to write about wind, more accurate value of G possibly. But this is just your easy answer. They're not actually particles. This would affect my answer. So they have size. And you get no marks, obviously, for writing about air resistance. You also get no marks for writing about the mass of the particle. Okay, so I hope that is helpful. And just try and remember that philosophy of what to do when you're stuck. Right? You're thinking, what information do I have? How can I use it? I knew they collided at C. I hadn't used that yet. And how did I use that? Well, I thought what made point C special is the point where they both meet at the same time. And that led me to think, I need to calculate how far P has travelled vertically and horizontally, because that will help me figure out information about Q. Okay, so let me know any questions or any other questions you want me to show. And yeah, have a good day.